Today we'll take a look at how to implement linear regression in Python. But before that, let me take a quick, I'll give you a quick recap because Raja and others still they want me to revisit the slope and intercept since they are quite new to these terms. Anyhow, so what is slope and intercept? Can someone tell me what is slope and intercept? What did we discuss, and how do you interpret? What were you what was your understanding, or what is your inference about that? Okay, let me just. Slope. Slope is nothing but, see, the slope helps us to quickly get an idea about the steepness of the line. How steepness of the line, right? Steepness of the line. That is what it tells us. What is the change in y when it changes? Okay, intercept where x value meets the. No. It's not x value meets the y-axis. Is no. It is wrong. Okay, the line, the best fit line where it touches the y-axis. That is what your intercept. The slope is something like the steepness of the line, and the intercept indicates what is the intercept? Intercept. See, there are a lot of definitions. The idea is very simple, and the intercept indicates the location where it intersects. We can say that where it intersects the intersects the y-axis. Okay, that is what it tells. Intercept and slope. The other way, what we discussed was the slope, the steepness of the line. Okay. So what do you mean by steepness of the line? The magnitude, right? So the magnitude of the slope it determines the steepness of the line. Okay. And for example, if the magnitude of the slope is more, the steeper the line and greater the rate of change. Okay, that is what you need to remember it. So we don't have to compute it manually, but however, right, in the interview, they will ask you what is the formula for slope and intercept. And it is good that if you understand the underlying mathematical formula for the slope and intercept. And yeah, so the slope, with the help of slope, we can understand how much y can increase when x changes. Okay, that is what it tells us. Okay, for example, I just draw something like this. For example, I have something like this x-axis. This is my x-axis, and this is my y-axis. And here, this is my 0, and this is my, let's 5, 10, and 15. The scale values are in 5, okay, and 20 and 25. And this is the one, and this is 0, okay, and this place is 0, and this is 1, 2, 3, 4. Okay, and if I put something like the line here, okay, and if I say y is equal to 2 plus 5x, what is the slope value here? What is the slope here? So this is my best fit line. The linear regression equation comes something like this: y equal to 2 plus 5x. What is the slope value here? The slope is 5. This is slope, right? This is slope. 5 is your slope. And this is what? This is what your intercept. See, the y is equal to 2. The 2 is somewhere here, okay, 2. And the intercept value is 2 here because the line, it touches the y-axis at 2 here. So 2 plus 5x. So the slope is 5 here. Slope is 5. The 5 is positive value. It is a positive value. So when x increases by 1, and y increases by 5, okay, the intercept is 2 here. 2 here. X increases by 1. For example, this is my x, right? When x increases by 1, it is going to be 5. And the x increases by one more value, by 2. In this case, right, it is 10 here. It is 10. It is 10. And next one is 3. 3 is something like here. 15. Okay. So when x increases by 1, y increases by 5. So when it is 1, when the value of x is 1, the y value is going to be 5. When the value of x is 2, and this is going to be 10. When the value of x is 3, and it is going to be 15. Okay, I have another scenario. Same thing here. Okay, let me just put other thing here. This is my x-axis and this is my y-axis, and 0, 1, 2, 3, 4. Here 0, 2, 4, 6, and 8. You have something like this, okay? And here, if I have my slope is something like this. So since it is going down this way, so let's know the y is 7 minus 0.4x. So what is the slope here? What is the slope here? Slope is negative 0.4. Negative 0.4. Okay. So what does it says? When x increases by 1, when x increases by 1, when y decreases by 0.4, and the intercept is, we know, right? And suppose you get something like another thing is, there's something like okay, you have you are getting something as not this one. And here I'm going to say, here you have 1, 2, 3, 4, something like that. And sorry, here, okay, sorry, this is -1, -1, and -2. Your intercept is -2 here. So y is equal to -2. And slope is 0 here. Slope is 0. In this case, slope. So that means when x increases by 1, the value of y will increase or decrease. Can you tell me now? Let's say -1 and -2. And just above this, okay, this is your intercept. Okay, your intercept, the line, best fit line starts here. Okay, and yeah, so yeah, this is the thing. Okay. And above this, you have 0, 1, 2, something like that, in the y-axis. Okay. And when y equal to -2, so here the -2 is the intercept in this case. The intercept can be negative value also. That is what I discussed. And in this case, what happens, since the line is flattened, we can easily make out that the slope is 0 here. Slope is 0. So when x increases by 1 unit, y will neither increases or decreases. Okay, y will not, it will not, increase or decrease. No, it is not -0.4. Here I did not See, all these three things are completely three different scenarios. Though don't relate each and each and everything. Okay. So here, there's a different thing, because here I mentioned the slope was minus 0.46, right? Here I did not specify slope. So y equal to minus 2. And this is the best fit line. That's what I said. See here, this is the best fit line, and this is the best fit line, and this is the best fit line in this case. Okay. And here the best fit line is straight line, and the slope is 0. Okay. And why the slope is something like in Tamil they say Sayu. I don't know in the Telugu. Telugu, if it is something bending thing, right? What do you say bend? Something like this, right? Something like, see, if it is something like this, then there is a slope here. Okay, it is bending thing. It bend. It is not a straight thing, right? It is bended something like this, right? So, but if something is straight line, there is no slope here. Okay, 0. So in this case, when x increases by 1, the y neither increases or decreases, because you don't have slope here. Got it? So this is how you need to understand the difference between slope and intercept. Okay. Okay. The next thing is, what is ordinary least squares? What is ordinary least squares? How many of you remember this? This is very important. That is the reason why I just repeat this topic again. Okay, the slope and just give me a second here. Somebody's calling. I'll come back in a minute. Okay, just give me a second. Okay, I'm back. Sorry, guys. Okay, so what is okay? What is the objective of ordinary least squares? Which method is used to find out the best fit line? Which method is used in linear regression to find the best fit line? Ordinary least squares method. Okay, what is the objective of ordinary least squares? Ordinary least squares helps us to identify or determine the optimal values for the beta coefficients. Okay. So yesterday I have drawn 3 lines. Remember, I have drawn 3 lines, and I have asked you what is the sum of square SSE, right? Sum of squared error. So which line is the best fit line, right? The line which minimizes the error. The line which minimizes the error, or the line I mentioned ABC. Can you please recall? Okay, ABC. Each line, if you see, this line is far off from this, and this line is far off from this observation, whereas this line is somewhat closer to all the values. Then this is the best fit line. So how did we say this is the best fit line? Because the error, this line minimizes the error. That means the intercept and slope, right? The intercept, with this intercept and with this slope, we are able to minimize the error, or the model can minimize the error. Okay. So the objective of least squares method is to identify the optimal values for the slope and intercept, right? So then we will have the line of best fit. So once we get the line, best fit line, so we can use that to predict the values of y given the value of x. That's it. So they will, this is very important thing. The best fit line. Okay, you need to remember this. 1 second, let me just. what is best fit line and how to optimize, or the objective. What is the objective of, what is the objective of least squares method? You just keep this thing in your mind. You have three lines, A, B, C. Right? This line is far off from these values, this line, but this is somewhat covers all the values, right? All the values in your data set, which means with these, with for this, this intercept and slope, for this intercept and slope, we are able to find out the best fit line. So I was telling you, I was trying to tell this point yesterday. If I dump you everything in a single session, you will get confused. That's the reason why I thought of going step by step. Okay, so this is the objective of least squares method. Determine the optimum values for the beta coefficients. What is beta coefficients? The beta naught, comma beta 1, beta 2, etc. Okay, so this is my intercept and slope. Find out the optimal value for the intercept and slope in such a way it can minimize the error. Right, so this one will help us to find out the best fit line, using which we can predict the values of y for any given value of x. Okay, and the next question is, why do I need to build a model? Why do I need to build a model? See, the actual values are there, and predicted values we are going to find out. This is my predicted actual, right? So actually is already we have the data, and why still we need to predict it? Because you have multiple independent variables. Your dependent variable is depending on more than one independent variables. Once you fit your model or train your model for any given combination of values or given combination of variables, if you wanted to do an estimation, it is possible with the fitted model, and also the model can learn the pattern. Okay, now what we will do is I just go to the Jupyter notebook and we'll start quickly fit the linear regression model. So there are two packages are available. One is the stats models, other one is the scikit-learn. Okay, and I just go here. Let's open this one. And guys, I'll tell you one thing. When you work with your Python version, whatever you install Anaconda in your thing, and if you get any error, don't worry. Okay, import numpy as np and import pandas as pd, and the next one is from sklearn dot linear model. But you don't have to memorize, but if you remember it, it will be good, because the interviewer, they will expect you the package name and all. Okay, this is a bare minimum thing. You should remember it, because if you say you're a data scientist, okay, and you should be knowing these basic things, metrics, and I'm going to import the warnings also, warnings package, because I don't want the warnings to be displayed unnecessarily, or it should not consume too much of space in my notebook. Let's see if everything gets installed. Yeah, this is what the point I'm trying to make. When you execute these packages, if you get any error, simply you go to do Control and go to Colab, Google Colab, and That's it. And welcome to Collaboratory. See what happens. These are all open source. One way it is good, but the biggest disadvantage is in case any error comes. For example, no module found, or the module is there, but within that module, some packages are not working fine. The entire package itself will not get imported. And don't waste time, don't break your head running, go to Google and search, what is the problem for how to install the packages and all. Don't spend too much of time there. It is a nightmare, I'll tell you guys, because we work on the Linux system. The Linux system, everything is perfect. Okay, and you try to install, because what happens here is when you try to install a new package, it will try to update the existing packages. Sometimes even the basic packages will not work in your local system. And the same thing is applicable on Google Colab. It's not that all the packages will work well on Google Colab. Some packages, maybe a deprecated package, an old package, it will not work. You need to take a call based on the type of the error which you are coming. Try to play, wherever it works well in simple term, you go ahead there. For example, in Colab, you are able to successfully install the package, you go ahead and do it. Another thing is, in the worst case, even in both my local laptop and even on the Google Colab, I'm getting the error, no module found. That is the worst case scenario. So in that case, what can I do? So what you need to do is you just go to Google Colab and type exclamatory sign, pip install something like, I forgot some, okay. Let's, stats pack, something like that. Okay, stats pack. And click on this icon, the video button. When you hit this one, no, stats models, that one. Okay, let it run. Okay, so you could not find, this is a wrong name. Okay, there is nothing like stats pack and stats models. Okay, and let me do one thing, stats models, right? So this is stat models. We don't have to install it explicitly, just for you to to understand how to install a package. Look here, pip install stats models. Using this command, you can install. So when you do this, you can see the requirement already satisfied, which means this package is already available. Some cases, what will happen is you are trying to install new package, but that has not been installed yet on the Anaconda. If that is the case, you can use this command, pip install stats models. Okay, or other thing is uninstall, pip uninstall stats models, and click on this. Okay, it will ask you yes or no. Okay, if you press Y, it will uninstall the stats models and then you can install it fresh. Okay, this is another way of doing it. But most of the cases, right, in Google Colab, it will work, but rarely in some cases, it will not work. It will throw some kind of error. That is a different thing. But the reason why I'm saying is don't break your head with the error and all. Nobody is going to question you while which package got failed, how you fixed it. Nobody is going to ask. That is administrator's responsibility. You can simply say, let's say in the real-time scenario, when you work in your data science project, if you get no module found error, simply raise a ticket with your on-site team. They will sit with, or they will take it up with the administrators, Linux administrator, and then they will fix it. It is the responsible Linux administrator. First of all, even in the development environment, you will not have access to install all the things. Okay, fine. So any error, smartly you can try here. Okay, here it is working fine, or if it is error, go here. All you need to do is understand how to train a model, how to evaluate a model, how to fine tune a model, how to deploy the model. That's it. Okay, don't waste time in installation error by right. Okay, Got it? So that is the one thing you need to keep in mind, because at the end of the day, they'll ask you how good are you in the algorithms. Okay, that is what is very much important. So, okay, the next one is I'm going to import the data visualization related package import. And next one is I'm going to say housing.df. So we are going to predict an housing price. I have a data set called housing data.csv that is available in my system. Separator equivalent to d colon, okay, here housing df. Housing is not defined. Okay, let me do one thing. SDF something like that. Yeah, the naming convention, the variable, we should not have dot in it. Okay, okay, this is the issue. And yes, it was SDF. I just click on it, run. But don't ever do this, do like this. Since I have oddly few records, I just type the data frame name. So you know all these steps. So far, whatever I did it, you are already familiar. Using read underscore CSV function, which is available as part of my pandas, I have ingested the housing data.csv into a variable called HDF. Now the HDF became a data frame, and the data of housing data.csv got loaded into this data frame. We could see that 4 columns are there. In this, price is the dependent variable, rest of them are independent variable. Here, the size is the square feet of your house, and the undivided share is something like common area, and parking lot size, okay, and then miscellaneous. This is other spaces, okay, and a terrace and other places, okay, and this is the price, okay, and we have basically 4 independent variables and 1 dependent variable. Now we will take a look at the data types of these data set, the HDF dot D types. All of them are numerical variable. Remember that to fit or train a linear regression model, all the variables, including independent and dependent variables, should be a numeric data type. Okay, it should not have a mix of string and numeric variable. Even if you have an independent variable, or if you have a set of independent variables which are in text data type, you need to convert that as a integer data type. Text data types in the sense, right? Sorry, the string data type for the categorical columns. For the categorical variables, you need to convert as a numerical variable. How do you do that? We do encoding. That we will see it later. And but remember that all the variables should be numeric if you want to fit a linear regression model. This is very much important. Remember this. And also, you are not supposed to have any missing values in the data set. Okay, SDF dot how do you find out the missing values? There should not be any missing values. Very good. So we don't see any missing values, or we have data in all the columns. Fine. And also there should not be any outlier, because but if you have an outlier, still it will work. Outlier can influence your model. Okay, linear regression model. It will drastically influence your model. I will explain it later. At this moment, just keep in mind you need to check, are there any influence, sorry, the outliers are there in the data set. HDF dot, you can describe. There is something called describe, using which you can find out here. The describe function will give you the 5-number summary or something. So mean and first quartile, second quartile, and third quartile, and maximum value, minimum value, all these things you can get. The statistical value you can get it with the help of describe. And this one will give you a fair amount of idea about outliers. So if you see the minimum and maximum, and the distance between maximum and the third quartile is not much. It is kind of okay, but if you see here 46 and 114, right, we could see some kind of outlier here. So what I'm going to do is, now I'm going to use a visual. Seaborn, we have something called pair plot to find out are all these independent variables, or each independent variable is correlating with my dependent variable. I need to check that one. Make sure that you are using the proper case. Price is a small letter, hence you need to specify small letter everywhere. Don't use a mix of capital and small letter and all. And I'm going to use the size of this image as 7. That's it. I don't remember other arguments, but if you know this much, that is more than sufficient. And when you double click on it, it will get maximized. And if you scroll, look here, I just explained this in pair plot. You can create more than one scatter plot using pair plot. Instead of creating the scatter plot for each and every variable, you can create multiple scatter plot in a single chart using pair plot. So you know very well what is scatter plot is used to find out the relationship between the two numeric variables. So in this case, we want we want to find out does the independent variables are correlating with my target variable. So MISC and park is not correlating well, whereas the size and why size is not correlating well here. There is some problem here. Okay, so what we will do is size and price. Size and price is, it's not showing anything here. Let me do one thing. I will just increase the aspect, or aspect is equivalent to 0.7. Invalid syntax. Sorry, here I did not put the comma. But any aspect is nothing to do with this one. And got an unexpected aspect. Okay, this is something weird. Why it is not? But anyhow, we have another function called the car function. What I'm going to do is hcar is equivalent to STF dot car function and hcar. So there is a function called CORR. Okay, it is available as part of Python, followed by your data frame name. If you type the function CORR, is a built-in function. It will give you the correlation between the variables, okay, and each and every variable. Size and size is one. So you need to ignore finding out the correlation between the same variable. If you look at this diagonally, so you can see 1, 1, 1, which means all these 1, 1 wherever you see. So those are all the correlation on its own. Okay, the correlation of on its own. And now we will find out the correlation between UDS and size. It's already given 0.7. So what is the range? What is the range of values for the correlation? So correlation, we use a notation called R. The correlation value should range between -1 and +1. Okay. So here the value which is closer to 1, it is good. And look here, the 0.7 is not closer to 1, right? Hence UDS and size is not correlating well. But we are not going to care about the relationship between the independent variables. We are very particular about the relationship between each independent variable and the dependent variable. For size and price, if you see the because the price is the dependent variable, size is an independent variable. If you see it vertically, the price and size have a good correlation, 0.80, which is closer to 1. Very good. It has a good correlation. Though it is not plotting it correctly here, it is showing it very clearly here. Maybe something wrong with the package. Okay. So here, but here it shows very clearly the size and price, these two are correlated very well. And UDS and price is somewhat, it is correlating well. And if you would click on it here, you can see it here, right? So the UDS. So this is the undivided share, not this one. Size and where is the UDS? Yeah, this is the UDS, right? So there is a correlation, but there are some outliers are there here. Fine, and I just leave it as it is. And okay, but this function is very much helpful. Instead, what I do is I will better rely on heat map. So here, this car function gives me the correlation between the variables, right? And what I'm going to do is I'm going to use heat map function, which is available as part of my Cborn. So here I just say HDF dot car function, comma, we have something called R naught equal to true, and PLT dot show. So this gives me a pretty good idea, and this is my dependent variable at the bottom one, and the horizontal one. What you are saying is okay. So these things are like your independent variable. So here also we can see it. Okay, ignore about this thing, and price and size. Look here, price and size 0.8. It gives us the correlation value also as part of this chart. So what we are seeing here, price and size is 0.80. Same thing we can see it here, and UDS and price 0.56. This is the one most of the data scientists, they use it to find out the correlation between amongst the variables or between the variables using heat map. And we can also print the correlation value here. So okay, so but here you can, if you look at the spectrum on the right side, this color, right? This color represents higher value, and darker color represents lower value. That means the correlation is less. Just by looking at this color itself, we can make out it is good. There is a correlation exists between price and size, and UDS is somewhat falling here, 0.6 and above, right? And sorry, 0.56, somewhat closer to 0.6. Good. And the darker the color tells us it has no relationship with price. Park independent variable and MISC independent variable, these two are not correlating with my dependent variable. Hence, there is no point in including these two columns while training my linear regression model. Okay, so what I'm going to do now is I'm not going to drop anything. We are going to include everything, and then we will see what is happening. I'm going to create a variable called features. That's what not equal to true will print this one, the correlation value here itself. Okay. By default, it is false. If you remove this, you will not see the values, the correlation value. And you have variable x. I'm going to create two variables called x and y. And HDF is my data frame. In the data frame, use these features. Okay, and I'm going to use another variable. HDF is equivalent to the price. This is my dependent variable. So x is holding the independent variables, and all these are independent variables, and y is holding only the dependent variable. Okay, and the next one is I'm going to create the. So if you are going to create and train the models, the next step is let's go ahead and create and train the models. Before doing the training, we need to divide the data into two parts. We need to split the data into two parts. One is training and other one is test data set. Okay. And there is a package called Sklearn. And as part of this, there is something called a train test split function. So using which we can split the data set into training and test. Okay. And from Sklearn model selection, import train test split. So in this case, the x is the independent variable. Here y is the dependent variable. Okay. Now what I am going to do is I'm going to use the train test split, using which we are going to split it. Okay. So here x underscore train and y underscore, sorry, x underscore test. X comma y. The train test split function, you need to specify the independent variables and the dependent variable. So in this case, the independent variables, the variable x is holding all the independent variables, whereas y is holding only the dependent variable. You must be asking this question, why should I use x, y? Can't I directly specify all the variables? You can specify it, but it looks so simple, very readable, right? So x is simple here, y is, right? If you specify only these two variables, it is readable, right? If you specify, let's say you have 25 or 100 independent variables, if you put everything here, it will be difficult to understand, right? So that's the reason why you can use a simple variable like this, random, like x and y. Okay, so what is random state? So the random state is basically to randomize the training and test data. This is helpful to randomize the training and test data. And you can also specify the test size data here. Okay. In this case, I did not specify the test size. Okay. And the default split ratio is 75-25. Training data set is going to be 75%. and test data set will have 25% data in it. So the train test split, by default, it splits the train and test split with the 75-25 ratio. Okay, now the question is, the train test split is a function. We have passed this three argument. Okay, this is fine. Random state is 100. So can I specify some other value? Yes, we can specify whatever value you wanted. You can specify it. Okay, and why do I need to use random state? Random state, for example, if you wanted to get the same output as what I'm getting it in my system while executing this, right? Then you need to use random state. For each run, this will not get changed. The randomly sampling the data set. See, when you use a train test split, what it does is it randomly split the data, randomly split the 70% data set, the training data set, and remaining 25% data set will get randomly sampled. Okay, since it is randomly sampling it, so each time, even in my system, if I run it without random state, what will happen is for each run, it will choose different training set data and different test data set. I don't want that to happen. So for that purpose, I'm going to use random state. So random state is to randomize the training and test data set so that the values will not change for each run. Okay, so the train test split function, it returns 4 values. This function returns 4 values in an array of X for training and Y for, the X for training and testing and Y for training and testing. Got it? This function returns 4 values. Which one? Train test. If you pass this argument, you'll return 4 values and return the train and test for X and train and test for Y. It's as simple as that. Okay, now I just click on run. Okay, I'm done with this, no errors, very good. And now let us take a look at the print randomly, or we'll take a look at the extrain dot shape. Triple 137. How do you find out the total number of records in your given data set? Same thing, right? 740. No, shape. Shape will give you number of rows and columns. Size will give you the multiplication of these two. So 148 records are there. Of the 148 records, 75% of the records are 111. Remaining 37 are your test data set. When you add these two things, 148 you will get it. So I did the train and test split perfectly. So what do you mean by 70? No, 70% is 1 month, right? Yeah. So that also will just check it out. 148 into 0.75. Very good, right? So this is the one. By default, it splits the train and test set with 75-25 ratio. Okay, and if you want to change this one, I just want to create a train and test split with 60-40, then you need to use something called test size. Okay, and you have something called test size is equal to 0.4. If you specify 60-40 ratio, it will split the train and test data set. Your training set will have 60% of data, remaining 40% of data will be stored in your test data set. Okay. And then next one, we are going to fit the model. Now we are done with the splitting the data set. Okay, the next step is we need to fit the model. So we can use stats models package and the scikit-learn package also. But here what I am going to do is I'm going to use we'll start with the stats models, and then we will proceed with first we'll start with Sklearn, and then we'll proceed with the second one. So the thing is here, I'm going to instantiate something called the linear regression. Name it, or I just say model. Model is equivalent to linear. I'm going to instantiate the linear regression function. Okay, and then next I'm going to use model dot fit. There is a function called fit. See, once you instantiate linear regression, it will be like a this is going to have the linear regression model and dot fit. So you need to specify the training and test data set. In our case, the training data set is xtrain, and the other one is ytrain. So here in the xtrain, it will hold all the independent variables. Okay, and the x test, the 75% of the data. See, that is what, right? By default, 75-25 ratio, the data will get splitted. But in the xtrain, it will have the 75% of the data for your independent variables, and 25% of data for your independent variables get stored in your test data set, X test. What is ytrain and ytest? What is ytrain and ytest? Please concentrate here. What is ytrain and ytest? Y is a dependent variable, right? The 75% of the values of your dependent variable get stored in the training set, y variable, okay? And the 25% of the dependent variable values are stored in the test variable, okay, in the y. You understood? See, Bala Mukhilan, I think you lost track. You did not concentrate. So that's why you need to concentrate from the beginning. Okay. See here, don't x, y, we splitted, right? Look here, we splitted it. I explained several times, right? What is this one? This function will return how many number of values? Mukhilan, tell me. Train test to split function will return how many number of values? You did not notice it here. That's why please put your phone on mute and don't get distracted, okay? Because if I repeat it, it will confuse you, okay? It will not confuse you. You know, it will annoy you when you watch my video, okay? No, Bala, my question, Mukhilan, my question was the train and test split function return how many values? This function, 4 values. That is what I explained, right? Okay, so you understood, right? So please concentrate here, and 1 second, I'll just. Right, so that is what here this you need to pass these 2 variable here, and you watch my video. I think you lost track. Okay, that's why don't get distracted. Okay, xy, and the xy variable. See, this is the whole data. So not whole, the entire data are there in my x and y. But the train and test split function, the purpose of using this one is splitting this into 75-25 ratio. How it splits 75-25 ratio? Because this one will not simply split xy as a 75-25 ratio. Instead, it splits the dependent variable and independent variables 75-25, and the dependent variable 75% of the data gets stored here, and the dependent variable 25% of data gets stored in test variable, and independent variable 70% of the data gets stored here, and the independent variable 20% of data gets stored in test data set. Okay, test variable. Okay, and that's how it works. Okay, here that's the reason why I'm using X train and Y train. So my dependent variable, 70% of my dependent variable related values are stored in my X train, and 25% of the independent variables values are stored in, sorry, 75% of the independent variables values are stored in this one, and 75% of the dependent variables are stored in this variable, because we are training the model. When you train the model, you need to use the training data set. To validate this model, only you need to use the test data set. The test data set have 25% data in it. Please concentrate here. See, I can repeat. Okay, done. We are done with this. And now if you wanted to, model has been fit. And what I do is I just again say model is equivalent to the output of this one. I get stored it in model. And if you want to see the intercept, print model dot intercept. There is a thing called intercept underscore. Okay, this is syntax. Don't ask me why underscore. Okay, model dot. This is my model. So model dot fit is a function method. Okay, fit is a method, and you need to pass the independent variable and dependent variable. The independent variables are stored here, 70%, and 70% of dependent variables stored values are stored here. So now we train the model. So if you want to see the intercept, you can see it here. And if you want to see the slope, also you can see it. And the one disadvantage with this method, when you use Sklearn, you will have to see it each and everything separately, intercept and slope and all. Okay. But we have something else called stats models. That one give you the comprehensive information about your model summary. Okay. Anyhow, we will take a look at it little later. And next step is we are going to evaluate the model performance. Now we have we have trained a model, or we fitted the model. Okay. And next thing is, see, now this is learned model. So next step, what should I do? So what is machine learning? Once you train your model, it will become a learned model, right? So now the model is my learned. This is the learned model. Okay. And I need to apply this model on where? I need to apply this model on unseen data. What is unseen data here? Test data set. Yes, Mukhilan, very good, right? Yeah. So here the unseen data is this one. So in this case, how we are going to do is we have a function called predict. Yeah. So we have applied the trained model on the test data set, unseen data. Look here, x underscore test. Okay, because the x underscore test is the one holding all the, sorry, this is the one holding 25% of the independent variables data in it. Okay, so when you show all the independent variables of your test data set to your model, it gives automatically the predicted housing price for the 25% of the test data set. Because my model was not seeing the test data set, but still it is able to make a prediction on this one. Okay. Okay, now we have trained a model, or we fitted a linear regression model, and then we applied the model on the unseen data called test data set. And next one is we need to check the model performance, right? So how accurate the predictions are. That is the important step. And next one is the model selection. Click on run. Okay, and here I'm going to use import np dot square root matrix dot mean squared error squared This is the mean squared error. I'll explain you what is this one later. And then we have something else called score. There is a function called score. Here, model dot score. This is my linear regression model, right? My model name is model. Linear regression model name is model. Okay, whatever name you want, you can give it. But here I have given the meaningful name as model. Model dot score. There is a function called score, and here x test, comma y test. What is overfitting, underfitting? How many of you remember this? I uploaded the video yesterday itself. See, this is my training model score, okay? And this is my test data model score. So 86, if you round it off, 87, and it is 90. Though it is not matching with the same thing, but still 87 and 90 is somewhat closer. Hence, we cannot say overfitting. Okay, I don't know, overfitting. Train model performs well, and test model not performs well. Okay, somewhat it is correct. I don't know. So overfitting is my model is performing well on the training data set, and it is not doing the best job in or good job in test data set. Okay, because if the difference is too much, the score difference. See here, I just pass the training data set to the score, and test data sets, values I pass it to the score. So we can compare, how well my model is performing on training and test data set using score function. The values returned by, the training score and test score is somewhat close by. Hence, we cannot say, overfitting, but there is a slight overfit is there, and we will see how we can address that one. So as I have seen here, right, the park and MISC, these two variables are not correlating well with this price variable. Okay, maybe if we can drop these two variables and if we fit it, let us see what happens with that. Okay, I'm going to do the same thing again. Okay, or that is an exercise for you all. Okay, I'll share this sheet, the notebook. All of you need, what you need to do is you need to remove park and MISC. Okay, and keep this one, and at the bottom what you do is write, simply copy paste it, the same thing you need to paste it here and remove the park and MISC, and then you create a train and test split for this. Okay, and then do the same, follow the same steps. Okay, and see what is your model score. With this, if your score is okay, anyhow, we will do it now itself. How long? It will not take much time because I do a little faster. And then the next one is, this is the one, right? That is not required. Simply, I just take this one and I just put it here. And I'll just simply take this one and I will put it here. But same thing, 0.90 only we are getting, not much. So 8676, now 8688. There is an improvement in terms of, see, higher the score, it is better, right? The score is close by 1, it is good. It is improving it. We could see an improvement, right, by removing the, if it is somewhat, 8 is 0.87 and 0.90 is somewhat close by. And we will take a look at another approach called gradient descent, using which also we will take a look at how we can minimize this error. Okay, and is there any way we can improve the score? That is a different topic. We will discuss it in the upcoming weekend. Can we take only size? What do you mean by size here? That's a good question. Yeah. What do you mean by size, Gilbert? நீங்க unmute பண்ணிட்டே பேசலாம். Okay, 1 second. Yeah, you can unmute now. You can talk. Okay, okay. What you're saying is, can I?
Size. Can we use only that size parameter, Satya?
Yeah, yeah,
Pictures.
yeah. Test size. Yeah. So
So
you can
let's see.
yeah,
Let's see what is the R value for that.
correct. So you can use the test size as 60-40 ratio. You can try that one also. 60-40 ratio. You can try it. Usually we will try to add some other variable to increase the score. Okay. Some other variable or better variables we can include it. But we have removed the variables that are not at all contributing, Park and MISC. Out that we could see a slight improvement. And we don't have data here. Another problem is we don't have data here. See, that's what one of my students, he joined with some company in Chennai. He was paid a very good salary as a data, but he was not having much data. He was breaking his head and kept on his sending the screenshot. My R square, my score is not improving. And then I was literally wondering, and can you share me the total number of records? He said it is 140 records. Man, 140 records, you cannot expect too much, because sometimes, yeah, we cannot generalize. 140 records, a very less number of records. Your model needs lot of data to learn the patterns. Okay. And if you use less number of data, and if you expect more score, it is not good. Maybe due to some coincidence, you might tend to get more score. But with the less data, how it can learn pattern? Simple common sense. Number of to include another variable or something that you cannot do any wonder. I told him the volume of data is less. What you are getting is only this much. We cannot do anything. Okay, you need to have more data. That is another thing. Let's say I have more data and still the underfitting, overfitting is there, and the overfitting is there. So in that case, you remove unnecessary features. Okay, unnecessary features that are not helpful to boost your model performance, right? You can remove it. Okay. Sometimes create a new column based on the existing column. Sometimes what we do is we create, so see, sometimes what we do is we will try to add some other variable, talk to the customer and find out are there any other variables which we can include it. And based on the discussion, if you think including another column as an independent variable in your model, it can boost your model performance. That is another way of addressing the overfitting. Okay. In some cases, what will happen is we don't have any other columns. And what you do is you need to try to create some derived features based on the new column based on the existing columns. Okay, based on some business rule or something like that, right? In that case, it might increase your. One of the cases it happened after we introduced an feature derived variable, the model performance went a little high. Okay, so fine. So as of now, we have seen this one, right? The how to select model version. Now, next one is I'll just show you how we can implement the same thing using the stats models. See, it is something like this. Okay, some cases, what will happen, right? You need to stats models. You need to import it more than once, something like this. Sometimes And then the rest of them I have done it, right? Okay. I just click on run. Cannot import name centered signal tools scipy signal tools dot py scipy. Okay, forget about this one. It requires some scipy. Okay, here it is giving some package error. Say import name size signal tools. Okay, what I do is instead of wasting the time here, I just go to the Colab. Yeah, so look here, it is working fine here. Okay, and the stats models, stats has, okay, the other thing is stats. You need to improve and import something else called stats models dot stats as stats. Now it is doing good job. Okay, and see, look here. Don't break your head in installing it. And see, in Windows, anything related to open source, it is painful, and especially the big data, other thing. Better you can, go to Google Colab. See, Google Colab is running on Linux only. Okay, for example, if you want to see what are the files are there, type pipeline and ls minus deltr. This is Linux command. Look here. Okay, and this is running on Linux. Okay, hence it is working fine there. But now the challenge is we need to upload the data file from here to cloud. This is on cloud, right? How do I upload the file from my local to cloud? So you will find an icon something like this. Okay, you need to click on this icon. When you click on this, you will find something like upload icon here, and just go here and housing data. This is our housing data.csv. Open. Look here, reminder, uploaded files will get deleted when this runtime is recycled. That's all. That means this data set will persist as long as you work on this session. Once you close this, the data set will get removed. At least he is giving that one. So now let us check whether this data set is available here or not. So I'm going to type the same thing. ls minus ltr is something like display the files in my current folder. Look here, housing data.csv got uploaded there, and click on code and create a new thing here. And here what I am going to do is I'm going to read this data set. HDF is equivalent to, okay, here I have to import all the packages again. Where is that thing? In the interest of time, I just go here and put all these things there. Okay, it is showing something like this, but I could see some kind of underlining thing. Okay, good. So it got loaded. Okay, now I loaded the data there. And the next one is we can do train and test split. In the interest of time, what I am going to do is I'm going to say model is equivalent to, sorry, is equivalent to SMF. Okay, SMF OLS. We have a function called OLS, and in this you need to specify the formula. Look here. This is the syntax. Formula is equivalent to the price tilde size plus UDS. Okay, that's all. I'm not going to use other variable because we know the other two variables are not much helpful. And data, you have an argument called data equal to HDF. In our case, dot fit you have to give at the end. Okay, it's a method. Okay, and now I just click on this one. We are done, and here itself I just say model dot summary. So compared to the Sklearn, this is the one gives you the comprehensive information about your model. Look here, you can see the dependent variable R squared and adjusted R squared, everything you can see here. And the intercept coefficient value, standard error, t statistic value, and p value for the intercept, and slope. Slope is size and UDS in this case. Okay, omnibus, lot of information it gives us here. Okay, and what we will do is we will discuss in detail how to interpret the model in the upcoming session. And next Saturday, I think we most likely will complete the linear regression, because next Saturday definitely it requires 2 hours, because linear regression is a very important thing, and logistic regression is a very important algorithm as part of the classification and regression. I'm not saying it's very important. If I cover it comprehensively here, the rest of the algorithms, it will be little bit easier for you to understand, follow. Okay. I will share these 2 files also. You can start practice it. Look here, don't waste time. If you get error, installing it, uninstalling itself, nobody is going to ask, how did you overcome and all. So end of the day, everything is on Linux only. Believe me or not, any data science project, real-time project, that's all running on Linux, Red Hat Linux. Okay, and better you focus there. And nobody is doing every, in Windows system. Training centers and the learning purpose, we can use Windows. Windows, a lot of pain, installing, uninstalling everything. Sometimes when you install a new package, what will happen is it will damage the existing package itself. Fine. So I will talk about the model output, how to interpret the model output in the next weekend session. Okay. Any questions so far? Okay. Since you don't have any questions, I'm going to wrap up the session now, and I will share the video tonight itself, so that there should not be any confusion. And also we'll share the script and start practice it. Okay. See you next weekend. Bye.